Oh.
Well, let's start. We're recording. So we are in the middle of the boot camp.
Sorry, that was the other project. Sorry, you're like, wait, that's not my project. Oh wait,
Oh, I haven't.
you haven't uploaded.
No. I have not done anything on that. No, this
But
is.
listen, I think that your project has like some serious use cases. I mean, nobody likes accounting.
I know.
Yeah, so let's start. We have some projects here. We're in the middle of the bootcamp, and we have some projects here that have been submitted. I see your project here, Fiona.
Yeah, I just haven't put.
No worries. You have a few minutes. You did not publish your. This allow me is the one that we visited yesterday. Yeah.
What's his name? Luke.
Yeah.
No, it's not. Sorry, you're. Isaiah. No, Juan, right?
Yeah. Let me go again. We have COFO, we have Impactivism, we have Web3 Converted, and allow me. Yours is your COFO. Yeah, no, that's good. That's good. Let's start by your project. Did you publish the web page here?
Not made a web page for mine. Yeah. What I did yesterday was I looked at the chat bot. Like I deployed that. That was the homework that I have.
Okay.
Published a website. Yeah.
But for example, if we do something like this,
I'm absolutely down. Put it into what is
Zero?
Yeah, V0. You know, I used this at work today to help something.
Oh, being used for is generating value.
No, it really is.
It's my special relationship.
Yeah.
He has a full name.
Do you call it by phone?
No joke. Like, look what I do. I have my action button.
And then you call it.
Wait, hold on. Hey, GP, what's up? GP, oops, my.
Okay.
Hey, GP, what's up?
But if you have your description here, at any point you can upload that to V0 now, and that can become your website.
So the thing is like I've just put more of a roadmap in there instead of like a description. I mean, but like just put like budgeting, forecasting, accounting, filing taxes, stock price valuation. It's like that's really like it.
Can we spend like 5 minutes going through Cursor and making the site?
Yeah, using V0 as an example.
I thought V0 to be a lot easier to use than Cursor. Maybe I just don't know.
V0 is a chatbot. Cursor is a dev tooling. They do different things for same results, and then for you to offset the things from V0 to Cursor, you would need to import this component and out.
That's what I did. I imported all the code into Cursor, and then I'm doing the terminal.
Yeah. Because
for your project, right?
Right now, V0, Bolt, we have Replit, and now they try to be this automated no-code platform that anyone could go there and deploy, but this still is not possible. It's getting closer and closer every week, but for now it's not possible yet. You still need to step in and code at some point and adjust and all. And every time that you try doing that prompting, it takes more time and much more frustrating than just go there and code the thing that you want to code. No, especially speaking that for developers. For non-coders, yes, it's a little more tricky. But for tech developers, this is super okay. You step in where you want to change, you do the changes, you ask the AI there directly. But now picking this description that we have here from your project and showing this here in V0, and it was like, 5 minutes, we have your website.
And it got the tagline without even much context. It's like intelligent,
Yeah, it's probably taking information from many other. David Young, your co-founder, it's taking information from many other websites and content that it has. Like,
basically, this is taking like the benefit that AI can have here is like it goes a level deeper because for smaller businesses like under 10 million in ARR, from my experience. There's so much software tool out there to do like budgeting. Like I was paying $3,000 a year to Carta to manage our equity. So like when you raise capital, like you have to register with this. If you're a U.S. company, you got to register with the SEC. You've got to issue stock to people because like if you hire somebody, you have to give them equity. Like if you go to Facebook and get Facebook stock, it's the same stock setup, but you've got to set up all that back-end infrastructure, and you got to budget, you got to pay invoices, you got to do all that. And
You can touch me with that doing that.
And accounting, payroll. Yeah, it's crazy.
Exactly. That's a whole other. That's the idea here is that this automates a lot of that, but it goes a level deeper than the tools that are out there. It's more personalized. That's what I would say. It's much more personalized.
Yeah. And my question is right now, what is stopping any of you, like speaking to the people in the recording here, from creating your website with your ID right now? Nothing. You could just publish them.
A few more days.
No, yeah.
Days.
Okay, give me the time, but let's just put this out. I'm generating here with V0, the COFO.
Yeah.
Let's see what is going to come out of it. And everyone watching this recording later, you could be doing that for your project right now. Pick your description that you put there in GitHub or wherever you have in your README, shove it to V0, use that with cursor, and let's see if you can generate a website for that for you to publish. Okay. If you do it in time for the demo day on Saturday, you're going to be able to demo this for all of the participants, the VCs, the invited. No, that can be.
Why not?
The sponsors, that can be a good opportunity, right? Oh, this looks fancy. Let me do that in full screen.
That's good.
Yeah, it's recorded. So what I did, it's 2 prompts. What I did was let me show that again. Technique, like super advanced prompt technique. I copied and pasted everything.
Yeah.
Then asked it a single question. Can you create a website for me? Build a nice website. And then I asked it, make it more fancy, make it dark themed, and that's it.
The dark theme, well done. Okay.
And boom, You put. That's good too. This is like a very sloppy job of prompt engineering. Ideally, we would give it context, we would give it the documentation guideline. You remember yesterday how we were drawing with Make Real. So ideally, we would make it informative enough. We would give it enough context so that it can do a good job. But even out in the blind, look at the results. Okay, so let's get this out. For today, we are going to give a look under the hood, what we are using there and those LLMs, just to explain why we have these kind of limitations. Because tomorrow and Thursday, we're going to speak a lot about decentralized AI, about decentralized agents, and we need to understand some of the technical details of those LLMs, especially the GPTs, to understand how blockchain can solve it. Because it's not too obvious for non-technical people, but as soon as we get a hang of those details, it's going to be quite more visual, quite more. It's going to be easy to understand why these kind of limitations exist and how we can solve them with AI, with Web3 actually, how we can resolve them with decentralized computing. So, for us to speak about GPTs, generative pre-trained transformers, we need to understand a bit about transformers. Have you watched the movies?
Absolutely.
Transformers, the cars that became robots now. Yeah, these transformers are doing the AI stuff that we're using. Okay, just kidding. It's another transformer. Transformers introduced it in this paper in 2017 called "Attention is All You Need." Like, remember the move from the music from Beatles? All you need is love. Yes, well, this kind of vibe. Attention is all you need. That was a new simple network architecture, the transformers, based solely on attention mechanisms, some sort of mathematical statistical algorithm that would be able to do this machine transformers would be able to compute the outputs based on these inputs with superior quality and in a parallel way. I know this is a very technical detail, but this unleashed all that we are experiencing. This in your phone is only possible because of that. Because before, everything that we had on AI with convolutional networks, recurring neural networks, they would have all of this process in sequence, which means that I would need a lot of CPU power to have that go. And one chat like we have in ChatGPT would take a week to process, usually. Because of the transformers, we could be able to parallelize these computations, calculation tensors, polygons, and all of that. And do you know a device that most people have in computers that can do parallel computing? For example, calculating polygons, calculating moving objects, light, shades. You know one of these? It's not the CPU. The GPU.
Graphics.
Yeah, the GPU. Did you know that all of the AI is only possible because the work that we did in gaming, you know?
NVIDIA.
Yeah. Because somehow, like, it's a match made in heaven. GPUs fit like a glove for using this kind of mechanism because it can do a lot of computation in parallel. So instead of going from process 1 to 2, 2 to 3, then 3 to 4, and then 4 to 5, they put this whole line of processing like in a field, like in a plane. Imagine like a fishnet, and you put your calculation through there, and it gets resolved in one step, all in parallel. So this allows like great performance for training this model, especially for inference later using GPUs. So this created the whole boom of AI that we have right now. And it's based in an embedding model that pick text of a string of words and input that in a form of vectors, actually tensors of numbers, that are converted to embeddings that are representation of these words that try to capture some of the semantic meaning of words. For example, if we try to sum words like apple plus banana, how much is that? True, that's a great answer. We don't have any definition of summing words like apple plus banana. We don't have any definition. Maybe we convert that before summing and all. But with embeddings, we can somehow create some semantical math. For example, the word man, woman, king, and queen, they all have some semantic meanings in our mind, right? These embeddings, they have a way of represent those words with these numbers, so that if I pick king minus man plus woman, it would be almost, or would be kind of close to the number representation of the word queen. Somehow they can capture some of this mathematical semantical meaning of a word just by doing statistics. Okay, so how much is a car plus a potato minus an airplane? I don't know, but it would be related to something there semantically with those embeddings. Okay, then they would have this transformer block, so-called transformer, that would capture some attention mechanisms and a multi-layer perceptron that would do a feed forward to the network, calculating those probabilities. And now, should we worry about this? No, just naming the things here so that later when we recall them, you know what I'm speaking about. So this transformer block picks from a sequence of tokens and transform this in another sequence of tokens. Then we have the output probabilities. And here is where we apply that temperature that we saw in the first lesson to sample or to pick a greedy search on the best probabilities there. That is an article, the Transformer Explainer, that we're going to go through this later. Let's see if I still have it there, the README. Yes.
You showed us this diagram.
Yeah, I mentioned it. Yeah. Yeah. So the whole thing that comes here is picking from words, data, visualization, M powers. You see how M powers is divided in two words, in two tokens. Users to, and this comes to a representation in vector. That would be the tensor representing data. That would be tensor representing visualization. That would be calculated here in this multi-head self-attention block, up to 12 blocks of these, and then that would be all joined together to these probabilities. The more increase the temperature, the more, let me close this, the more options I have in the end. The less I put the temperature, the less options I have here. Visualize is always the winner. Let me do sampling here. So if I try something, for example, the word strawberry has a count of R's of, then let's generate. Is this going to do any kind of reasoning? Is this going to do any kind of math? This is going to do any kind of powerful reason, thought, and blah, blah, blah. No, it's just going to predict the next token. And the next token is 1. Boom, we discovered why we have these hallucinations. Because this is not doing any computation on the semantical meaning of the amount of R's on. It's just relating these words with what's trained by the training algorithm, the training phase, to relate these words to other words. So if I increase the temperature a bit, we're going to see that we have the answer 1, R, 10, 2, 3, 5, all of these as probable answers. Okay? This is what's happening under the hood. Okay. So there's no intelligence here. And everything that comes here as part of the input gets stored in a place called context. We're going to see about it later. It's very important. This transformer, this architecture, like, changed a lot on the landscape of what we have on AI. Let me show you 3 examples. Understanding search. Google started to use a model called BERT. It's not a GPT. It's a bi-directional encoder. Yeah, bidirectional encoder something transformer. I will always
representation.
Yeah. Bidirectional encoder representation from transformer. Bidirectional encoder representation from transformer. That's good. Yes. Hey, come on, Eddie. Good. So they implemented this word for Google search. So for example, before, of course, Google was using the AI for all the time, but it wasn't using transformers in this search. So before using BERT, when you ask a question like this, United citizens can travel to Brazil without a visa, or would need a visa. This is going to try and search in a database what would be the most probable outcome, the most probable website to put for these people based on search engine optimization. And then the first result is United States citizens can travel to Brazil without the red tape of visa. But that was not the question. The question was if Brazil travelers to United States need a visa. So the Google search got it the opposite, because it was most related, statistically most related. When you ask about traveling to Brazil, it's much more probable a United States person doing tourism in Brazil than a person in Brazil traveling to United States. After using BERT, they could capture the semantic meaning of this question, and they would know, okay, this is not a United States citizen traveling. Actually, it is a Brazil traveler going to United States asking if this person needs a visa or not. And then the first answer is exactly that: the United States Embassy in Brazil, with the result telling for Brazilian travelers and not the other way around. So the bird can capture the semantic meaning of a question by using transformers. The second example that I have is for proteins using AlphaFold. Yes, it can go way beyond text. For example, do you everyone know about protein foldings? Hello, just have it here. How they try to calculate that for vitamins or for drugs and all.
The DNA.
Yeah, for DNA, but also for like how to manipulate or how to synthesize this protein for pills and all. So this is a complex problem that they have been studying for a while, and they had all of these models like from 2006 to 2014 16. It was almost in the same accuracy. They couldn't increase nothing, almost nothing of accuracy at all, until 18 and 19 they started. In 20 they started using transformers, and they almost double the accuracy of these models just by using transformers on it. Another example would be translations. The first 200 languages translation within a single AI model was achieved by Meta AI using this NL, no language left behind model that was using transformers. So you see there are different kinds of benefits or breakthroughs that we can achieve because of this architecture. So why is it that important? Why we're making a big deal of it? We're going to see it here. It has a lot of whenever you're using transformers for these tasks, you're going to see some examples later. It has a lot of dependencies in the pre-training data itself, because transformers is not an architecture that can reason, that can produce outputs. Like, it's not a direct probabilistic model, universal model for the whole universe of words that we have. Actually, no, it is a way for us to train a model using these transformers. Let's say we started from zero without any kind of information. It's going to give wrong information from everything, of course, but then we can use the transformers to adjust the model. I skip the important explanation here, that we have some weights. This is the correct word. We have some weights relating each word to each other word, each node to each other node. So whenever I would train a model, I would pick a wrong answer and measure how wrong that answer is and how much I would go back until that answer is correctly. And this is heavily depending on the data that is there. So even if I pick the best architecture like DeepSeek and I put it with bad data, I wouldn't have a good model. Do you know why OpenAI is facing problems of creating more intelligent models? Have you seen the news about that? Ran out of data. There is no more data accessible for them. Like, they run over everything. Every piece of paper thrown in the street, they went over this. Every newspaper, every blog, every article, every book. Yeah, and then they run out of data. Like, humankind has not produced enough data for a super engine. So these kind of models, no, yeah, they went through literally all data. Yeah. Yeah, but probably will eventually.
I think they probably know already. Just think about like all the stuff at work. Like, if you're at work and like you need help with something, you're gonna ask ChatGPT, even if it's blocked on the computer. Like, use it on like use your personal device. Yeah.
So you see how data is an important factor here. The model itself, of course, was what breakthrough. It was in 2017, like 8 years ago. Of course, it has evolved a lot. A lot of people working on that, but the model itself is not what makes the model, the mathematical model itself is not what makes the AI so intelligent. It's the data on it. There is some entropy on data that even if you pick another model and feed with almost the same amount of data now, you're going to have the same kind of limitations. So we're going to see these transformers in work with this is a good call out here. We're going to see it in work with a library from Hugging Face, because there are a lot of AI courses out there that go for weeks explaining how to build transformers from scratch or how to implement them on top of frameworks directly. And of course, that's a delicious kind of information to have now, but it's not practical. We're going to build our AI stuff without actually touching the implementation of transformers itself. So we're going to create a pipeline with this transformers library. Let me show that for you. We're going to create a pipeline with this transformers library, and like with 3-4 lines of code with Python code, we can do tasks like text classification, information extraction, question answering, summarization, translations, and image generation, and all of that just with a few lines of code. So if you search online for this kind of material, you can find week-long courses on text classification, week-long courses on image generation that can be summarized here with one line of code. Not say that you shouldn't study that, it's just that we can skip by using this kind of platforms of this kind of libraries. We would have a tokenizer for this kind of models there that would bring the strings to tokens, because the models cannot operate on strings, they cannot only operate to tokens, not like Web3 tokens, okay, like numerical tensors. And then we're going to use some sample data sets that we have available. This means that if I have the data and I have the model, the transformer, the GPT, for example, here, we can calculate the AI output without OpenAI, without giving away our data, without paying with our credit card. Okay. And no, they are not going to sue us or anything like that. It is normal for us to like run AI without OpenAI. They invented ChatGPT, but most of the people that come to this kind of bootcamp, they know AI because of this last wave. Was there a while ago, and we're going to run this kind of models without the use of ChatGPT or anything included of OpenAI. Okay, so let's get started. The philosophy of these libraries is that it requires almost no previous knowledge at all in AI or machine learning, thanks to how they set up this library. Okay, so it is built for anyone, hands-on practitioners or engineers that just want to download a pre-trained model and run it, and it should be as easy and fast to use as possible. So we're going to have a limited number of user-facing abstractions to learn. In fact, there are almost no abstractions. We just need to handle these kind of objects that I have listed, and then we can start getting computations out of this. And this is the part that you can complain, like, isn't it easier to run this with OpenAI? We just then pay them $1 and then run this for us. Yes, it is. But I'm going to make a point up to the end of the lesson today about decentralization, about safety, about privacy. So this whole explanation is going to make a bit more of sense. But yes, when you pay OpenAI, they handle all of this for you. I know that most of you don't have big hardware there for running this model, so I've suggested that we started on this experimentation with a Google Colab that can be used for free. It's like an online hosted environment for you to try out things. But later, when I do the introduction, we can we can run this on our own computers with these loaders. Okay. For now, you don't need to worry with that. Let's open this Google Colab, and I'm going to guide you through some exercises so we know what is happening under the hood. Okay. We're going to start on exercise number 1, just getting started with Google Colab, for you to create an account here. Okay, click on that link. Here I'm already logged in, but for you, the first time logging in, you might need to create an account. There is a pro version of Google Colab that would allow you to have more cloud credits to run everything here. It's not super needed. Okay, for us today, the free version should be more than enough.
Is this like a product under? Sorry, is this like a product under Google Cloud Platform?
Yeah, it's more for students. It's not so developer facing, but you could run developer
Is it
things
like
there.
Kubernetes?
It's like Docker,
Oh,
out there, but
It's not a just a product. It's like a people suite product.
oh,
Yeah.
oh.
We can.
Because I'm like thinking like even like the icons like host like real-time database
Oh yeah.
like BigQuery. I'm like I didn't see this one.
Yeah. No.
no, this is just for students. Even though like you can run things here, when you abuse yeah, for free. It's mostly for just study Python and things related to that. They have a lot of Google courses here. It's a very good resource actually. And it's a shame that it's not very popular. I get a lot of other resources there that don't have this kind of capability. But let me show you how to get started here. We are going to create, I was just there for some reason. I'm going to create a new file like a test notebook. Let me start a new notebook here. You don't need to do that. I'm just going to show around, but if you want to try out, you can. They even have an AI to do things now. And it sounds like a Google Doc. Like you can create like a title, like my test notebook. And you're going to have some formatting, some formatting comments. Where are they, by the way? Text. Okay, there is a code block. I got confused by my own notebook. Here is a code block that you can start coding, but you can click here to add a text cell that you can pretty much like write anything, and it's going to have those formatting tools for you. For example, I want to make this a title. Okay, my test notebook. Now I want to make this some bold text. So it's basically like a normal Google Docs that you can do Markdown and start documenting. Okay, but also you have these code cells here. Let me delete this one. Let me add one below. Added code cell, and you can start doing things in Python, like variable a equal to 1. And then I can add another code block that is like variable b equal to a plus 2. Okay. And if I run these code cells, like they have this little play button, one result of one cell is going to be carried over for the next ones. They remain in memory, no? So at the same time, it's a document that you can run things and have outputs. So for example, I'm going to ask it to print B. And it's going to print something. Let's see. 3. And if I do another block, like C equal to C plus B. I know it's a recursion, and I'm going to just type C at the end, because then it's going to print it. Yes, it was. C is not defined yet. That's good. Yeah. Let me do the plus equal. It's going to make more sense, of course. The B, C. We need to define C. Okay. That defeats the whole purpose of what I'm trying to do. Let me do that. C equal to 0 here. And then if I do this code block, I have C equal to 3. Okay. But if I do it again to 6, to 9, to 12, you see? So this is picking what is in memory and doing the operation again and again. It's not like a structured code. Now, depending on where I click, different things are going to happen. Okay, make sense?
Typed it exactly.
Yeah, maybe we should put the thing about.
Well, yeah, it's also on notebooks. If you run it, it'll work. You delete it, it's still holding memory.
Oh yeah,
So, yeah.
it has a lot of trash. Yes.
Yeah. There's no real garbage collection. in notebooks.
And the cool stuff is that you have a machine here that is hosted for you like for free. You have a bit of disk, a bit of RAM. We have a lot of VRAM here available. If you upgrade to Collab Pro, you can have beefy resources here for you. Some beef computer. Love it. So this is just explaining about the Collab notebook before we start using it, okay? And then imagine you can do functions, you can import files, you can do a lot of crazy stuff here. And then you would print, you would have the documentation. Okay, so starting here with this example notebook. That is a notebook already pre-made for explaining the pipelines for Hugging Face. We can go step by step, understanding the code on the line, understanding the operations on the line, just by clicking on this button. We are going to have an instance attached to this notebook that is going to run all of this code for us. So even if it requires more computational power than what our computer, what our laptop is able to provide, that is no big deal. This is all running in the cloud, okay? So it installed some dependencies here in this first step, and now it's going to run this pipeline. Remember, I told that it's just a pipeline for transformers using a sentiment analysis pipeline. It is a textual processing, text to text, that is going to give the sentiment analysis from 2 points of data. I love you and I hate you. And we're going to see what is the result from this. Can you imagine like a mathematical equation that inputs a string and outputs a number of that sentiment, if that string was good or not? It can be a very difficult mathematical equation, right? Yeah, like here we're using transformers. It's a simple model called DistillBERT, a distilled version of BERT, uncased, fine-tuned for English and all, and gave the output that the first one was positive with a score of 0.99999, and the other one was negative with a score of 0.9911, blah, blah, blah. So what if I add more things, like I like potatoes. New York is too cold now. And what else?
You can say what bad things.
I like pineapple on pizza, like this, right?
No. Same. Yeah, same. It's good.
Tell me on. Yes, but pineapple pizza. That's a good one. So the first one is positive, I love you. The second one is negative, I hate you. The second one is positive, but you see, with a score of 93, not a solid 99, but it's close. New York is too cold now, negative 99. And someone has put pineapple on pizza, of course, negative 299. This AI no thing, right? Pineapple pizza, oh my god. Funny fact, I had one of those in California, you know? They're not so bad. Because if you disregard the pineapple, they're great, you know? Okay. So this is like a very complex statistical, mathematical processing now using transformers that we can run in like 4 lines of code like a breeze. Okay? Like 10 years ago, you could win a Nobel Prize with this. Right now, it's like 5 minutes introduction to the theme in the bootcamp. It's impressive how we are evolving. And we can pass the model that we want to use for this data. So for example, for a different model, maybe like a Californian model, they are going to evaluate this differently. They might like pineapple pizza, and they might like code. So we can pass in the pipeline indication of what kind of model we're going to use here, an open source model. And we have positive, negative, positive, negative, negative, but with different. Actually, no, look, they scored, someone put pineapple pizza as neutral. That's outrageous. So, wait, so this kind of operations, here we are using a very, very, very abstracted library to do that. This kind of operations, textual operations, can be processed on top of textual data using this kind of models, okay? We're just starting on this, don't worry too much. So we did this sentiment analysis. Let's give a look on the transformers library in more depth with this other collab notebook so that we see some of the complexities of it, not much of it actually. There's a whole tutorial on it, like why transformers, the whole explanation. This is getting a little aged though, but it's still a good piece of information. And we're going to see that for transformers, we have those 3 steps, and this is going to be important for us to speak about decentralized AI later, that we have the pre-processing that is going to make the model as a result of the pre-processing. And then with the model, we can do the post-processing. The model does not change in the post-processing. When we ask ChatGPT a question or we give it an instruction, the model is not going to change. This is a common confusion. We can have some memory that is updated, that is part of something called context, but the model itself is the same. Did you see on Monday that some of these models, they have like old information? They don't know that Trump is president and all, because the model was trained in the past in this pre-processing step and then stopped it. We don't have this new training, we don't have new data passed for the model after that. Okay, this is something called the training process. After I have the model, I can do all of those post-processings. For example, I can do text classification. I'm going to pick this text, stop this other one. Dear Amazon, last week I ordered an Optimus Prime action figure from your online store in Germany. We start installing the other things as we speak, because this can take a little while, because I did not install this. Did I? No, I did not. Wait. Stop this. Stop. Yeah, sorry about that, people. I forgot to install the whole thing here. So we have this text review from Bumblebee that was complaining that he ordered an Optimus Prime action figure, but when he opened the package, he discovered that he was sent an action figure of the Megatron instead. So he was very impacted by this experience. Now that we have the things installed, I'm going to run this code block, and then I'm going to create this pipeline of text classification. And I'm going to feed that for the text classification pipeline. And this is what is going to happen. I'm going to have a lot of pieces of this text lined up one by one, like we saw in that image of the transformer explained. And we are going to pass it for BERT for it to condense this in positive and negative at the end. We did something wrong here. Yeah, I messed this. It's so simple. I just need to follow step by step, and still I have messed this.
Isn't the hugging face token?
Not yet. I just messed it up. I can reload. But you're going to see that is the same example that we did a while ago. It's going to use the DC bird, blah, 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 for doing this fine tuning and all. And this is going to create this output, this computation based on that model that we had. Here I have two other examples named entity recognition. Like I'm going to ask from this task, what was the correct place that I mentioned Amazon. So an organization, it was here. Optimus Prime is Mixelos. Here, Germany is a location. So this is some sort of computation that the model can do too. So instead of going from false to true, it now can condense that into like location or person or something like that. The model can go for like question answering, text summarization. Let me go for the recurring part. Going beyond text here. Let me see if I find. For example, this question here. What does the customer want? So we would have a QA pipeline with this question with the whole text as context, and then I'm going to extract. The answer is an exchange of a Megatron. How does the model know that the Bumblebee wants this? It is the same thing. Instead of going from a tensor to 0 to 1, it is going to go for a string. It's going to try and compute the best string that would answer this. Using reasoning? No. Using statistics. And we know that this is not good enough. So it all comes to the model, the data that it was fed, and the preparation for this kind of test that we are running. So now we are going to return to that big image that we had. Where I have it. Yeah, transformers. This big image that we had. So now we have a bit more of context to understand what is happening here. Every time that I give it a question, it is going to calculate the most probable token one by one. Next token. Just like when we are typing in the phone and we are answering someone, it's suggesting the next word based on the words that we mostly use. Okay. So if you want to dig more on this content, that's the whole explanation here for all of these parts, all of the calculations that happen in the middle, the probabilities, and the temperature part that we saw, and the whole explanation for it. Okay. We're going to focus in one part. We have here, they speak about the layers here. Okay. Let me increase the zoom a bit. When these models start, let me pick the first picture. When these models are not trained yet, they have initial value for all of this. For example, 0. All of these little nodes here are 0. They multiply 0 by 0 or something. And then I ask a question. For example, uh, the first person to step in the moon was, and then it's going to answer 0.00000. I compare that with the correct answer, calculate the error, and then I go back. What kind of weights do I need to have in each of those little balls so that I can do this kind of calculation correctly? This is called back propagation. And I do that with one question, two questions, three questions, 1 million, 1 billion, 1 trillion different pieces of texts. I know the text, I cut it in half, I pass it half of it, and I see if it can come with the other half correctly. This is going to create these layers, is going to create these matrices of values of Q, K, V that they can be calculated based on these embeddings that I'm passing, multiplied by all of those weights that are stored. These weights are not a product of the calculation during the inference. They are stored in the model. Don't know if that's too heavy, but this is the key point here for us to proceed. All of these models that we have been trying before, they are basically a collection of these weights here. Imagine a lot of layers, and I have those connections between them. This connection is close to the other, but it's further from the other. This is why they call neural networks, seems like neurons connecting to each other. And these weights are the actual guidance of what is going to be the input in the other side. This is what I calculate when I'm doing the pre-training. But I'm trying to go with this. So when you are using those GPTs, those generative pre-trained transformers, they are totally based on this pre-training data that they have. Although they can follow complex structure like chatting, like you saw building websites, like the image and all, they actually don't understand the inputs that they are receiving, and then don't understand the outputs. They just answer based on patterns and probabilities. Have you seen those examples like how many cigars a pregnant woman should take? They suggest like 3. How many rocks should I eat by day? They suggest some number. 1, yeah. Because those are reasonable answers based on probabilistics, based on probabilities. The model is not wrong. If we look at this picture, whenever we answer that strawberry has 1 R, it is correct. Oh, but the strawberry has 3 R's. No, look, it is mathematically correct. According to the weights, according to the training data, and to the process, mathematically is correct. But we know that factually this is not correct, you know? Here lies the danger. Here is the most difficult knot to resolve right now in the whole AI industry. Like $1 trillion, a quadrillion-dollar question is how to make silicon reason. And we have those reasoning models, but they're not reasoning, you know. They are still prediction, next token prediction models with some fine tuning for reason and all that we're going to see tomorrow, but they are not actually beyond this. They still are based on patterns and probabilities. They are still stochastic errors, remember these terms? Okay, now we are seeing a little under the hood. And they do not retain the information that they process in the training phase. So they forget the inputs and outputs after processing. You need to feed them again and again. In fact, you can even alter them. Like you ask an AI, what is your favorite color? And then the AI is going to answer, it is blue. And then you can alter all of that, and you can change the context, saying that the AI answered red. And then you can ask, okay, why do you like red? And then the AI is going to answer as if it has answered red before, because it doesn't remember that it answered blue. It has no brain like that to remember things. So you can gaslight the AI on believing different things if you manipulate the history. This is how people even jailbreak these AIs and all, because they can change this context. there is no way to store within the model, within the processing the model, all of this information. So imagine you are chatting with AI for 1 hour. How many chats you have with AI, if you want? Thousands
Per day?
in a year, like last year.
I started my relationship with my AI like maybe 3 months ago.
Okay, so then
We
what?
have like 300. But it knows me really well. It gets it wrong a lot, but it knows me.
But let me tell you that if you take the context out of it, it's going to totally forget who you are. Yeah, we're going to realize that now.
I mean, if I stop paying for it, it's gonna forget.
No, if you create another account, or even like if we're going to run the locally, so you can see that better.
Put in all like the writing that I do like for all of my art projects for the past 20 years.
Yeah, look, and this all is being stored in a place called context. Use it to have a length of like 8,000 tokens, 16,000 tokens. Now we have models with quite big context, like 128 tokens. Each token is a word, give or take. Some words have like 2, 3 tokens, but you can imagine like 1,000 words, which is enough for a book, 100,000 words. It's enough for a book, a big book, or a lot of books. But eventually it's going to start to forget things. If you tell your whole life, at some point it's going to forget the first things that you told it. So if you're writing a book or a documentation or even a website with an AI, it's eventually going to forget the things and it's going to start hallucinating. So this context management is very, very important for us to do with AI, especially tomorrow when we're going to start seeing about decentralized AI agents. Want to ask something, Tony? Tony, no, Navani? Yeah.
So regarding context, when do vector databases come into play during that sense?
Yeah, this is a very common technique. Let's see if I guess I'm not going to speak of that soon. Let's include that now then. It's a very important technique because when you cannot feed the whole information inside the context, you still need to get all of this data. Let's say like petrochemical industry data now for you to do one summarization, and you have like terabytes of data. What people usually do, they employ a technique called retrieval augmented generation, RAG, so that you can put all of your information inside a vector database that has some sort of similarity search, so that when you want to bring something important from the data to the context, you can pick exactly the chunk of the information that you need and leave everything else out. Okay? Like my kid, he already always select the meat and leave the vegetables away when eating, because he's more interested in that chunk, so he doesn't need to eat the whole plate. Okay? And then he doesn't get the candies. That's how it goes. So this kind of technique can save you from working with a whole lot of information and picking just a bunch of it. The problem is all of those vector databases, they pick things by similarity, not exactly by relevance. It's very difficult to compute relevance. So whenever you are retrieving some information, sometimes you are finding the most similar information, but not the most relevant information, which makes things very difficult to work with in the first place.
So would you say that like an AI would be better with something that's like more math based or like quantitative rather than qualitative? Like for instance, like in my case, like I want to train my GPT or my AI to like trade an up and down market.
LLMs, like at least these kind of GPTs, they have no mathematical reasoning at all. They make like payouts wrong. They even let's try here like 10 multiplied by 12 is calculating 6. D. No, is D A equivalent 1 equal? Is D, let's generate another. This is based on GPT-2, but okay, let's give it a go. Sum of you see, this is the brain of the AI. It's the sum of the number.
Kid that has trouble with like fingers because it's like wait.
It cannot count it. Actually, because of positioning. It is part of the it is part of the stable diffusion thing. Like you cannot use positioning. So
So why are people worried this thing is going to take over the world?
because like a lot of things. First of all, because of hype, who profit from hype. I told that in the first lesson. And second, there is this mirror symbolic math from deep mind, alpha geometry. So for example, there is this alpha geometry released at the beginning of last year that could make geometry deductions using something called neurosymbolic processing, this alpha geometry, that could solve that. It's not an LLM like these ones that we have, but it is able to do that. Okay, so it was better than gold medalist. Like the alpha geometry was almost better than the gold medalist, was better than the silver medalist, and the previous state of the art was like very bad. So this is going on. This doesn't have so much attention. I'm not much of an expert to know why, but these kind of things scare me much more than O3. This kind of thing can like be reasoning in a silicon. That would be crazy. O3 is still based on this. No reasoning, just guessing numbers and all. They have some fine tuning for reasoning from chain of thought now, but it's like chain of thought is not thought yet. This would be neurosymbolic processing, would be processing not only with the outputs of textual data, but actually the concepts itself, like joint embeddings and all that would probably get us closer to AGI than this kind of thing. And it's funny because those billions or trillions of dollars spent in LLMs, they are not going to be used here. Probably it's going to be all wasted. But it's cool. We have cool chatbots in the meantime, right?
So they're completely
It's like, hold for 1 minute. Let's do a metaphor. Where is the highest place in New York? World Trade Center, maybe. If we go up from here, we get closer to the highest place in New York. Yeah, but eventually we are going to hit a ceiling, and then we would need to start building on top of the ceiling to get up. It's much better to go down the building, go to the street, take a metro down to the World Trade Center, and then climb up again. Because here we have a ceiling, we cannot go that further. Even though whenever we go up, we are closer, but we can't go that up. This is the way that we are going with those LLMs. We are going up, yes, definitely we are going up, but it would be much easier if you climb it down, went this path like this or other places, and then we would climb up. And DeepMind was acquired by Google like half a decade or so, and nothing like went public. And Google is very chill with the AI race and all. I can't say anything. I'm being recorded, but I have my guesses here. Yes, Eddie.
Two questions. So to piggyback on what you just said regarding the building stuff, it sounds more like there's a better implementation for graphic-based processing architectures out there. Or how this one sounds like. What's this called again?
Alpha geometry. Yeah, this is just one example that would demonstrate the neurosymbolic abilities for geometry, solving Olympic level geometry problems.
And the second thing regarding the RAG, when you have a vector database, what's the benefit of putting a RAG
You can use both for RAG. Retrieval augmented generation is every time that you retrieve something and shove that in the prompt. instead of manually showing that yourself, you can pick like whatever corpus of data you want and automatically append that, uh, postpone or prepone that to the prompt when passing that for the AI. You could do a manual rag. You could search the web, pick the most important results, and then append in your prompt if you want. But it takes a lot of work. So those rag, they do it manually. They do it automatically with vector database, with Elasticsearch, with whatever you want. You can pull data from there. Yeah. Okay. So yes, the GPT is going to forget this information when it gets out of the context. The context has a limit, and the GPTs, they don't learn or improve every time they process an inference. They can be fine-tuned, but this is another thing. Like they can be trained further in new data, but when you are just doing the inference, there is no other learning. Okay, so we have these examples. From all of these, you might have met some of those are out there, like ChatGPT, of course, Gemini, like Bard that was before, Bing AI, Cloud, Pi, Grok, all of these. And there are a lot of discussions about reaching AGI, the thing that we were just discussing about as 24. Now let me update that for 25. There is still no feasibility for this kind of artificial general intelligence yet. Okay. See where we're going to go with this. Let's do a short break, like 5 minutes, restroom and water, and then we're going to start running these GPTs for inference. Okay, short break, 5 minutes.
It's crazy.
Yeah, let's get started. No more.
Oh, we were talking about like tickets and raffles on the where they used to have the mopeds.
Yeah.
We were just talking about mopeds and explaining.
Like almost a car. And you still have to see like,
Oh, I love stupid bike rides.
I terrify myself. I
Weird thing, I can barely walk in this cold. Imagine biking. No.
not in the I don't if it's below like 45 I or whatever.
I bike here
Oh,
from Grand Central.
Yeah. Whoever use it.
don't bike in the middle.
It's the cheapest, fastest way to get around.
Yeah.
It scares me. Biking is too crowded.
Yeah, let's return to the content. I just wanted to make one heads up before I forget that tomorrow we are changing the venue. We have like a special guest. We're probably having a lot of more people, more pizza, more drinks. It's going to be cool. More networking too, and we're going to start AI agents. So it's a super hot topic. So we are prepared for more people. Yeah, Yeah, we can make a lot of money with it, Who is making money with the GPT inference? Yeah, there are some companies doing it, actually. But this is the thing. Tomorrow we probably are foreseeing like 30, maybe 40, maybe 50 people. So we're going to go for a bigger venue in Hadron, in Station 3. We're going to have Coinbase visit, a Lincoln from Coinbase visiting. So it's going to be packed. Remember, it's like what was the name? Broadway. It's down Broadway. Okay, we're going to see the venue for the invite. You are all in, of course, but do subscribe to the Luma again. Just make sure that we're checking everyone. If you forget, like it's not going to be a big deal, but it's good. And invite your friends too. This is going to be a big day for the boot camp.
It starts at the same.
Yeah, same time. It's basically a continuation. Ideally, we would have the same venue all days, but we had a little thing, but now we solved it. So, what happens when we make this API call for OpenAI and then they solve this inference for us? This task of running this inference, of passing a text and computing what is going to come out in the other side, requires much less computational power than the whole amount needed for training those models. Don't know if you saw like how much OpenAI spent to training GPT-4, how much Meta is spent training Llama 3, do you have ideas of how much? Thousands, hundreds of thousands, millions to billions, yes. Because they where this cost goes for, a lot of it goes for payroll, of course, for like fine tuning and refining with human feedback, yes. But a good chunk of it, a majority chunk of it, goes into GPU bills. And what is the most valuable public traded company that we have right now? Because gaming is so hot, right? No, because their GPUs are using for training. Inference is not that much. It's important to have good GPUs for inference, but for training is like over the roof. So when you're doing these inference through APIs, they can be a good option. Like they have these trained models. You cannot run inference on GPT 4 or 1 in local because the name of the company is OpenAI, but the model is closed. So these API calls are good, but they might not be the best option in some cases. For example, using sensitive data, if you need reliable uptime, like we faced OpenAI outages a lot of times. Last bootcamp in December, you remember in the third lesson, we were doing image generations. The API was off for the whole day. So if you need reliable uptime, let's say you are doing some medical services, you have a medical robot that runs on OpenAI, it cannot stop, it would die. If you need ultra low latency, like you need the first response to come in milliseconds instead of waiting for the whole internet connection, especially if you don't have internet connection, like you are running that in a forest or in the deep of a mine, or you are using a submarine. Yeah, there are some edge AI devices that you could speak with the AI without internet connections. If you are using OpenAI and you don't have internet connection, you are out of it. Like airplanes, not most flights right now they do have internet connection. Like when using custom models like Llama 3 and all, then you cannot run Llama 3 with OpenAI. You can only run the models that they have. So these API providers may offer a convenient way to run those inference tasks, but you might be affected by using them. For example, pricing can change, can increase, features can change, you can face rate limit, you can face vendor lock-in, you can face downtime. Imagine your application is doing like $1 million per day, and then OpenAI stops. You have $1 million less. You cannot swap it. Okay, you swap for another, then thing changed and all, or they increase. Let's say you are making $1 million, but you are paying 900,000. Okay, you still have 100K profit. That's good. I wouldn't complain. But then they increase the pricing 11%. What's going to happen to your profit? Boom, negative. You're going to become a worker for them. So all of this can happen. It's very real. So this is why we need to study running those inference tasks locally. Although it's more complex, may require more resources and all, it may remove some of these limitations. So for us to run these locally, hello, welcome. For us to run these models locally, we could be using these frameworks like we talked about PyTorch and TensorFlow and all, like we saw with the Google Colab notebooks. But then you would need to configure these, would need to make them work properly. This process, the whole process can be overwhelming for beginners. You can use one of these installable tools, like distributable tools, that you can simply install for your computer and then run the task locally. I'm going to demonstrate one that I have installed in my computer. You can test any of those later in your machine if you want. Like Olama is very easy. There is LM Studio that was showcased in the Apple Intelligence Lounge that like is getting very famous and all. There is the old tech generation WebUI, like the OG, how it all started and all.
Which one do you like?
Like Olama, GPT-4Owl. I like actually all of these that I put here like for some different reasons. This GPT-4Owl, the first one in the list, it is open source, and you have at the same time a simple install link that you can simple download. So it's like the best of both worlds. They still have like an enterprise version, paid version, but for example, you can download and run DeepSeek in your device with it, if your device can hold. What processors do you have on these Macs here? Are you using a Mac? No. Okay.
No, it's not. It doesn't work on my.
Yeah, depending. Yeah. Do you have M3s or M2s?
I have like an
Mine's an M2.
Oh, yeah. Yeah, for Intel, M1s are kind of more difficult to get them to work, but M2 or M3 can work. Any NVIDIA GPU can work. Some AMDs can work. Some Intels,
The better for
NVIDIA. I have a NVIDIA here with 470, and it's good for running like 13 billion models that I wouldn't expect to run like consumer grade devices with quantization now. I'm going to show this application, GPT for all. But Mac M3s are good. It's just that sometimes they require more tweaking. And not to mention that if you can buy a Mac M3, you can buy like two GPUs like this. But
yeah.
this goes without saying. So with this application, I can have some local models downloaded to my machine. I can download more, like add models, and I just search them in the internet. How to download GPT-4? No, like we're speaking about open models. Believe me or not, there are people that spend millions of dollars and publish those for free, which is crazy, but it happens. It's very good for the industry. For example, Llama for Meta. Have you heard about this? It's one of the first big model contributions. We have like uh, Mistral, we have DeepSeek, we have NVIDIA, we have Quen, we have many of those open model families that you can pick here and download. For example, I'm going to download this DeepSeek distilled version. I guess I have one of these installed already. Let me see. Yeah, I do have a lot of models. No, I don't have this yet. So for example, I can download this DeepSeek R1 distilled version with Quen 7B. Let me see if they have with Llama. Okay, with Llama is going to be better for my system. I'm going to download the DeepSeek R1 distilled version with Llama 8. It's going to be 4.35 gigabytes. I was downloaded, but couldn't complete. It's going to take a while. And this is going to be in my machine. I can talk to it even when I'm in an airplane. It's going to be private. It's going to be secure. It's going to be low latency. It's going to be slow because I don't have like a beefy GPU here, but I can do things like this. I'm going to pick here for chat. I'm going to choose a model that I have downloaded. For example, this small LM 360. This is super fast. Like, hello. I'm going to ask here, and it's like almost a OpenAI speed here. Like if I ask it to tell me a big story.
So this will work if you're not connected to the internet.
Yeah. This is locally. And this is a very limited LLM, like only 360 million parameters. But it can do a good job on some things if I give enough context. If I pick a bigger one, for example, I can run Meta Llama 3, 8 billions. And if I ask something like tell me a long story, it's going to take a while. It's loading. Sometimes it gives an error of out of memory. Tell me a long story. So the more parameters the model has, more intelligent it is, yes, but more heavy it is. So I'm going to have less tokens per second, and I'm going to have more latency until the first token. So those two things are going to be impacted. How to make a long story short. Okay, you see, I'm okay. I'm running 20 times more parameters, yes, but still it is getting there. You see how it's one token predicted at a time? And if we are patient enough, we're going to have an answer here. Questions?
Just want to what's the total tokens per month?
Ah, probably fine. In this application, you can do the settings here. Model um, 4096. Okay, so it's going to go for a while. I'm going to stop this. And you see that the quality. This is another thing. It's not only the speed of the generation, but whenever we run a big model without enough resources, it's going to dump down. It's not going to have enough parallel memory, so it's going to produce. It's going to speak slower, and it's going to hallucinate more often. It's going to get out of rails more often, but it is possible. It was going like a 1 token per second average, and it was doing this generation locally. 8 billions is a small model yet, but if we have enough processing power, like big GPU, like if anyone can donate NVIDIA 5090, okay, I could probably run 13 billion models here that could answer way faster. And if I had a cluster with 4 H100s, I would be able to run the Llama 70 billions. That would be a quite intelligent model. And
80 grand, right?
yeah, not that much. A cluster for now is going to be like 25, 30K.
I thought you need 4 of them.
A cluster of 4. Let me check that real quick. How much is 800?
H100?
H100 price. Oh, per GPU. Yeah, I was looking at the A100. Yeah, the A100 is like 8K. With 4 of those, you can run one of these. You can. The H100, yes, this one is beefy.
If you can even get one, it's going to
But
be
wait.
so hard to get.
Yeah.
Question.
Yeah.
So like, when you're running an AI, your own AI, you use algorithms to process them.
We're going to get there. When we are running AI agents, you see there is a whole story building within the whole lesson. That is a suspense in there. When we're running this through an API provider, let me see if I get it there. Yeah, the conclusion is here at the end, but we're going to get there. When you are running this through a provider, here actually the next step is just listing these models, like downloading the models. I have some of here that I could suggest you to look at, and that's it. No big deal. When you are using one of those APIs for serving those AI agents that we see out there in Twitter now, anyone could cut them. Anyone could stop paying the bills. And more, anyone could tamper with the answer. How do you prove? Let's say an AI is going to pick a random winner here to earn $1 million. How do you prove that the result was actually processed by the AI, or a person went there like a middleman and changed the string that was coming off? How do you prove that? You saw, Pione, You said that you are not technical, but you have a very good vision. You saw the problem coming, right? And most of the people interacting with these agents, they don't know this. They don't connect the dots. That actually what we would ideally have is like a local way to serve these models, local way for us to have access to this kind of processing power so that we don't rely on middlemen, right? But even the smaller models, like even these small language models like these, may be a suitable option for us to run in devices like the Pixel 9 phones. They can even run like local AI, the Mac minis, they can run local AI. So there are some edge AI devices that are quite good, but they still don't perform anything like the models of 10 billions or more of those LLMs like DeepSeek and all. They're way, way better. So being able to run these models remotely without relying on unsafe third parties is still a big challenge for the whole AI industry, as of 2025 at least. Decentralized computing may pose the perfect solution for this challenge. And then finally, we know why we're seeing Web3 in this bootcamp. Because Web3 represents the next revolution of the internet, the post-web, as Navneet was saying the first day, characterized by decentralization, by being able to share computation, to coordinate different players in a structured way with incentives for them to collaborate. Okay? Who here is completely new to Web3? So that it's like never saw a smart contract. Okay, that's good. Anyone else?
I haven't seen a smart contract before.
You have like written Solidity or something before?
Seen it, not read.
No written. Okay. Have you experienced with Web3 before?
Every time I spot it there.
Okay, that's good. That's good because otherwise, most of the things here would be very boring. By the way, what do you know of Web3 before we get there? Web3 seems a solution for this, or it's like sounds crazy, or it's making sense.
Just looking at
Okay,
what's possible.
let's see. It seems feasible, or because there are a lot of people joining these too, just for the sake of joining the hypes. I know it. I've seen that, and in fact, it's unfortunately is even the majority. In these boot camps, we're going to see some of these are actually delivering that they actually have solutions for decentralized computing with Web3. We'll see Aura protocol that is straight on that in the Friday's workshop, and tomorrow Coinbase Agent Kit that is using agents with AI-enabled payment is still not solving the decentralization part on the inference, but it's solving the monetization part. Two different problems, but they are very important. So in the Web3, started with Bitcoin, started like one cryptocurrency and all, we had this first concept of creating scarcity out of nothing by introducing the concept of block space, and anyone that would include a transaction in that block space would need to pay in a specific cryptocurrency. And this demand for block space for almost a decade was almost zero. No one wanted to include transactions in that block space, like for half a decade, let's say. But when this block space started to get more uh, competitive, more demand for it, the price for that cryptocurrency, for that token to give access to that block space, started to increase because of market and demand. Let's say we have a train here in New York that goes for nowhere, and that train is always empty, and you pay one crazy train token to enter that train. No one is entering, there is no value for crazy train token. Anyone that would help pushing the train would gain that crazy train token, and anyone riding the train would pay crazy train token for getting on board. But as the year passed, the region around the crazy train line got more valuable. People started building houses, started building commerce, offices around the line. So the demand for this ticket increased. And then the price for that ticket increased. This is something similar to what we have with blockchains. We have a block space for put information there. In the example of Bitcoin, it is transaction information, assets coming back and forth. But for all the smart contract enabled blockchains, this can be any kind of data. Can be files, can be processing, can be balances, can be scores of games, can be votings inside governance, inside DAOs, can be leaderboards, can be ballot, can be lotteries, can be a lot of different things. This is all part of something that we see as blockchain. Different from like peer-to-peer networks, different from like decentralized file stored blockchains. They are enabled for us to have secure, impenetrable information related to each other. That would be the base of Web3. Okay, so far is basically what all you all know, right? So what if I told you that we could deploy programs inside these blockchains called smart contracts, self-executing piece of codes that dictate the terms of agreements between persons and entities interacting with that network just by the definitions in the code stored in that smart contract. Have you interacted with smart contracts before? Like you said that you have seen some,
Oh yeah.
for example,
I don't remember.
Uniswap maybe, or something like this.
Yeah, I think it's like a Snoopy contract. I forgot.
Yeah. Let's do a step back then. Do you all have bank accounts, right? Mobile payment processors now. Where the data is stored? Servers in someone's control. AWS probably, and all of this information is governed by some enterprise software that they have. Some kind of bytes one of these. Who guarantees that your balance is that exact balance that they did change and you didn't know this? Wouldn't you go and check that before now? And sometimes you want to withdraw a big amount and they start asking you questions. Wait, it's my money. I cannot withdraw. I need to give you reasons why. So you see how there is a power play there, how there are some mechanisms that, not say that they are wrong, but that are sitting behind of you and your assets. There is no instant execution of you having the asset and you getting it, you transacting it. You may need to go for a court trials for suing someone for getting that money. With smart contracts, we have, for the first time of in the humankind, an ability of having instant settlement just by proving computation. This would be very difficult to do without a decentralized computing, because anyone that would have access to this as a single decider or a single person would have like too much power, especially in an environment where everyone is anonymous. Would you trust an anonymous person with your money? They would flee with the money. You don't even know how to sue. So these kind of security guards, they need to be there. The whole system wouldn't exist without these. So one smart contract can exist in the blockchain, governing all of the transaction of these assets without intervention of any person itself. Just the hosts of the blockchain, the people hosting the blockchain software itself, they wouldn't be able to change the information. The only thing that they could do is like everyone would shut down their computers. That is possible. But there is no incentive for people to do that. They could, but you just need one node online. That is enough. You can have access to your assets and you can prove that you have ownership over it. Sounds interesting, especially when we apply this for solving the computational problems of AI inference and AI training, something that unfortunately we are not going to have time to speak about in this bootcamp, but it can solve both. In this bootcamp, we are going to see the decentralization of AI inference, but this is going to give good hints of what can be done with the training part itself. So all of you haven't written any smart contract yet, right? Do you want to right now? You can do it in 5 minutes. Click this link here, open Zeppelin Wizard. Do you see this here? I assume most of you have this wallet installed since this is a Web3 bootcamp. So, yes, it was my bad. I forgot to include this prerequisite. You would need to have this wallet, MetaMask. Okay, raise your hand if you don't have it. You.
Well, I gotta set it up.
Yeah. So let me give you 2 minutes for that. This is a crypto wallet that can sit in your browser. It is not going to store any money. In fact, if you do have money in this, create a new one in another browser. Do not lose the one that you have, because you're going to use that for development purposes. Okay, so you're not going to use a credit card. You're not going to use anything here. You're just going to create one of these wallets, and we're going to use that for interacting with that smart contract. Why do we need to create this wallet in the first place? When you use Facebook, you don't need to pay. When you use Instagram, you don't need to pay. When you transact in your bank account, like having access to it, usually you don't need to pay for everything that you do. In the blockchain, you have to, because no one is going to work for free for you, you know. Why Twitter is working for free for us? Because they sell our data. They are not like philanthropists. They are making profit over our access. So whenever you're interacting with Web3, we need to have a wallet, because each of those interactions are going to be paid, okay? It's good that we can have faucets. So Ethereum faucet. We're not going to have a faucet for Ethereum itself, but for example, this faucet from Google is going to allow us to get free money in something called test nets. Are networks that are not like real production networks. We can just receive this money, Ethereum Sepolia, for example, in this test network from Google itself. Yes, Google is giving cryptocurrencies for people. So I can paste my wallet address here. I'm going to pick it here from MetaMask. And I'm going to ask some money. I do have some money already. I don't know if they're going to give me more, but I can try. Yeah, they're sending me some tokens. This is the Google. You can just search for Ethereum faucet. They're going to be the first result. And you are going to find this Google faucet here. Try that on your side. Did you order the food? We need to coordinate it better. Questions here? The faucet? Got distracted with the pizza, sorry. Yeah. So we received the testnet tokens here. It means that we received free money, but don't worry, you don't need to submit that for your contability or anything. your account or anything, because it's going to be in a test network. Okay, so it's fake money. Don't get too excited with it. And now going back for this wizard, we can configure a token in this wizard with any options that we want, like a Subway sandwich. I want extra cheese, double bacon, no lettuce, you can just pick whatever options you want here. So let me close this. From the instructions here, we are going to select the pre-mint options, pre-mint checkbox. So I'm going to check the pre-mint, and I'm going to put a value here. You see what I have in the documentation, to a value higher than 0. Okay, so 10 is higher than 0. And this is going to be my token. I don't need anything else. I don't need this permit. I don't need anything else. I just need this pre-mint amount that is going to be an initial amount of tokens of the deployer, and this is a smart contract coded for me. This is not AI generated, okay? It is some pre-made algorithm to generate that smart contract. This is using a language called Solidity. It is a programming language for smart contracts, a different way than those programs that we have been using, because here we are targeting a very specific execution environment called EVM, Ethereum Virtual Machine. It's different than our computer. Like, we cannot do like console log, we cannot access to files, we cannot do API calls. It's a different thing. So it is useful to use a separated programming language just for that. And then by using Solidity, I'm going to write this smart contract in an IDE made for that is the Remix. So I'm going to click in this button, open in Remix. I'm going to see it nearby from download, and it's going to use this IDE. The first time that you open it, it's going to ask some confirmations, this development environment that is going to allow you to connect your wallet, compile that smart contract, and deploy to a network that you have connected. Okay. I can guide you through this if you want to do it right now.
What testnet are we on the net?
We can put Sepolia. I'm going to show that. You can use actually anyone. If you like layer 2s, we can use like Polygon is hosting this bootcamp. So for example, we could use Polygon Mumbai or Cardano, for example, that are testnets from Polygon, and then deploy this smart contract there. Yes, I do have tokens with it. You can pick any network that you want. Let me show test Polygon Amoy, for example, and I have Cardano too. I have tokens. Good.
Mine have been shown.
You MetaMask?
Yeah.
The faucet takes a little while.
Oh, okay.
Did you paste it?
I can look at it. Yeah, I put it in here and then said that
Oh. Because they denied you, right?
yeah, well, I did it once already, so it says 1 drip every day. So because I did one with this mask, I just made an account.
Okay. Let me show you a bit of a little bit tech. In the left corner here, you're going to have a network selector. Okay. This is exactly what I was saying. My bad, I did not show that for you. And then you're going to scroll down. You're going to see a checkbox to show test networks.
Yeah.
And then you're going to find Sepolia there.
Oh yeah, I see it.
Yeah, and then you can add all of those other networks just by clicking on add here too.
Oh, there's money.
Yeah, there's money.
Yeah, fake money.
If
Yeah.
only it was real.
Let me go with this Polygon ZKM testnet. It's called Cardano. And I'm going to compile that smart contract with this big blue button to produce some bytecode. And with it, I'm going to deploy and run this smart contract there. You want a few minutes? Okay. And I'm going to show how to connect all that. See if you have it. Okay, it's still requesting tokens. Did you manage to get it?
Me. The remix.
You last tree. Okay, yeah. It's not super necessary for it to verify. In fact, let me explain about this to you. If you lose your passport from your MetaMask, it is impossible to recover it. No one can recover it. Not even Vitalik, like if you call him all day, he's not going to be able to recover your wallet because it's generated randomly when you create it. And it's not saved in a database. You could write it in a piece of paper, but if someone finds that paper, you're done. They would steal all of your precious meme coins. This is a whole subject. Yeah. But like if someone brute forces that drive, you're done. Yeah, they could take your USB drive. It's very hard to secure crypto. There are like multi-part wallets. That there are many things that can be done, but there is no solution. The only solution for being 100% protected against people stealing your crypto is not having crypto. Otherwise, you always have that risk. Yeah. I even like forget there's so many landfills case like the people trying to search for hard drives on that. People forget the password for hardware wallets. Yeah. There are a lot of things like, and then you put in an exchange. Yes, they can recover your password. Yes, but they can also go anti-gox. They can also go like FTX. So it's never trustable to leave custody with other people. You know? So it's a whole topic. Why I'm speaking about this, creating a wallet, they ask you to save your mnemonic because of this, because there is a whole big deal with wallets. So when you copy this smart contract for Remix, you can compile this bytecode that's going to be deployed the EVM, and then you can connect this injected provider. This injected provider is going to communicate with your MetaMask here. Whatever chain that you select is going to be used when computing these transactions, when computing these operations. So if I just want to deploy this smart contract, I can click on that orange button just by filling this one parameter. This token is going to mint a pre-mint of 10 tokens that I have configured here. I have filled here, but OpenZeppelin created this code here for me from a specific recipient. So let's say I'm creating this token now, and I'm going to give this address of this person the initial pre-mint. I'm going to give it to myself, because why not? I coded it. I'm going to give it to myself. So I'm going to just put the address of the recipient here, my own address. I'm going to transact. This is going to ask for one approval in my MetaMask. Every time that I send a transaction to the network, I need to approve. I'm going to confirm that transaction. And when this is confirmed, I'm going to have this live in the network. In a decentralized network, here using Polygon Cardona testnet that is equal to Sequoia, that's equal to any other testnet that you use out there. Okay, this transaction is still pending. Let me see. Oh, it's confirmed. Let me view on Block Explorer. And here, it was very fast, very cheap and very fast. Very good there. The job that Polygon is doing here. Okay, this means that once this transaction was included in this block, nothing can undo it. This smart contract is live. Anyone at any time can just interact with it. So for example, if I ask my balance, there is a pane here for deployed contract. Let's interact with this function called balance of to ask the balance of this specific address, my address. I have this amount. Now at any time, without no one asking me any questions, I can transfer this just by calling this transfer operation here. So this is the last exercise, calling transfer here. I'm going to transfer tokens from my address to another address. So I could pick the address of any of you here and transfer this. This would be processed inside the blockchain. Unreversible, anonymous, secure, private, censorship resistant, and all of these features that we want. Yeah, if someone hacks me, it's impossible to undo. So, quick questions. Where the code is hosted? You know? The blockchain distributed to all of the participants of it, all of the nodes running it. So it's not possible to delete that code. It would be copied all over. Who has control over the application? No one. Can I charge a license for it? Can I protect it, like for someone, like geo-block it? People from Argentina are not going to access my application for some reason. It's not possible, you see. Where the data is stored? In the blockchain too. All of the nodes running there are in control of that data. And what if someone wants to manipulate or censor the application? It's possible. So we're going to stop here in the introduction to decentralized computing. That is this new paradigm that allows users to run applications in this decentralized network of computers, peer-to-peer computers, decentralized nodes, and now using blockchain, using smart contracts and all. And we are going to see in the next 2 lessons with the workshop from industry experts, how this decentralized computing is solving real problems in the AI industry. Okay. We have pizza time now. Thank you all for participating. We have
So like, when people are talking about like blockchains that are very like AI focused, people often talk about Near. Near is an EVM, or it's.
we could have someone speak about Near on Saturday, right?
Oh, okay. Never mind.
Oh, yeah. No, because Near is one of the possible sponsors that we were really doing. As a quick exercise, I just wanted you to push a little more information on README. Everyone listening to this recording, to please pay attention to this exercise, because I would ask you to try and exercise your mind. You should talk to your group too, to come up with at least one really useful feature for each of those technologies, AI and Web3, for solving real problems within the project that you are envisioning. Okay, how AI and Web3, describe the AI and Web3 components of the project in the README, and try to come up with at least one, no need many, just one really useful feature for each of those technologies. Okay, that's good. Thank you very much for participating. See you all tomorrow. We are in a different venue tomorrow, okay? Remember about that. And we are going to see Agent Kit, building agents, which is super cool. Thank you. Good, 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 good.